All right, the type of transformation we're going to look at this time is reflections. And this is something that is not difficult when we think of it over the x-axis or the y-axis. Those are actually two pretty simple um, things to do. It gets more tricky when we have to reflect it over an x equals line, a y equals line, a y equals x line, a y equals negative x line, and then when the shape or the point is overlapping the line that you're trying to reflect it over. Uh, so this part will be a little bit more difficult. This part will be pretty simple and intuitive, but hopefully once we talk about these, they'll be as simple to do as this up here. Um, a reflection, just another good word to probably write down for reflection would be a flip. We're flipping it over a line. Just some things to think about here. Anytime you do this, if you can identify what the line is you're reflecting over, it's going to be really easy because you're only putting the dot or the shape the same distance away from both sides of that reflection line. For instance, if this is my reflection line and this is my dot, this dot would be the same distance away from the line on this side as it is on this side. Now, that's a pretty simple example, but it really isn't that much more difficult than that. And if you're pretty good at picking out patterns, you will be able to pick out some different things with the X point and the Y point as we go through here that might make this process a little bit simpler. You may be able to kind of memorize some patterns if you can discover those patterns in the first place. Otherwise, we'll just rely on this. For these notes, you're going to need graph paper. Now, I don't know if you're going to be able to do everything on the same sheet of graph paper or not. You'll just have to see what works best for you in this situation. All right, the first one we're going to talk about is just reflecting it over the x-axis and the y-axis. Okay, it's pretty simple. The x-axis is like this, the y-axis is like this, and here's our shape. Okay, I'm just going to start with one of the points in the shape right here. And if I were to reflect this over, let's start with the y-axis. The y-axis is the vertical axis. I need to make sure that my point, and it's always good, I'd always like to draw that in there just to really reinforce where that line is I'm reflecting it over. I need to make this point the same distance from this line on this side as it is on this side. So if you'll notice, it's 2 away from the reflection line. So on the other side, I need to make it 1, 2 away from the reflection line. Okay. Now, same thing if I was reflecting it over the x-axis. Here's the x-axis right here. Okay, that's the horizontal axis. How far is this away from the x-axis? 1, 2, 3, 4, 5. So I've got to put it 5 away on the other side. 1, 2, 3, 4, 5. There's that point reflected over the x-axis. Now what I'm going to do is I'm going to think about this as more of a rhombus type shape here. Or at least a parallelogram type shape, and I'm going to reflect the whole shape over. Okay, we've already reflected this point over. Sometimes when I do this, if you're having trouble, I like to assign numbers to match up. So like 1, 2, 3, 4. I know that this point reflects over here, and I will just label that also as 3, knowing those were the same things. So now if I come over here, this is 1, 2, 3, 4 away, so I need to make it 4 away on the other side. 1, 2, 3, 4. Okay, so that was my point 2. Point 1, it would be 1, 2, 3, 4, 5, 6, 7 away. So it's got to be 7 away on the other side. 1, 2, 3, 4, 5, 6, 7. Now remember, it's a mirror image, so it's going to be flipped around. And then this one, I could count, or I could just see, well, these 2 points, 4 and 3, are 1, 2, 3 apart. So I could just go 1, 2, 3. And I could put it right there, and that would be my point 4. If I connect the lines, I've got the same shape, just reflected over the y-axis. Now I can do the same thing if I do it over the x-axis. I already did this point. That was number 3. Point 4 is going to be the same distance, 1, 2, 3, 4, 5. So I'd go 1, 2, 3, 4, 5 right here. That's my point 4. Point 2 is going to be 1, 2, 3, 4, 5, 6, 7. So I need to go 7 down here. That would be my point 2. And then this is on the same kind of level as this one. It's just over 1, 2, 3. So maybe I just go over 1, 2, 3 and put my 1 right here. Now I draw my shape. Remember, it should be a mirror image of it. And it is. And that's all we really have to do for this one. This is reflected over the y-axis. This is reflected over the x-axis. And the basic principle we adhere to here is same distance away from the reflection line. 2 away over here, 2 away over here. Same thing for everything. All right. Now, this is not going to be very difficult either, I don't think. But we're going to reflect it, and I'm going to change this number, and you'll see why in a minute. But we're going to reflect this over the line x equals 2. Now, here's the confusing part. This is not reflecting it over the x-axis. It's actually reflecting it over x equals 2. Okay? And now, the only thing is we have to identify what x equals 2 looks like here. Now, here would be a great note to put down. Whenever we have these x equals, your line is actually going to be the opposite of what you think. Normally the x-axis goes this way. It's going to go the opposite direction, so this is actually going to be vertical. We're doing the opposite here. So here is my, here's 2 for the x right here, so I'm just going to go over to 2 on the x line, which is what we want to do, but now my line is going to be vertical instead. So this is the line, oh that's horrible, but this is the line x equals 2. You would think it would go the other way, but it's opposite when we're doing these things here. So I'm just going to make, there we go, perfect. Okay. Now, this is not difficult now that we have our reflection line. This is x equals 2, and remember, we're doing the opposite. This is a great note to put down here. Okay. So now I'm going to do the same thing. If I have this triangle, and I'll connect everything on this triangle here, we're going to have a mirror image over x equals 2. So if I go to count, I am 1, 2, 3, 4, 5, 6, 7, 8 away from our reflection line, x equals 2. So I need to be 8 away on the other side. There's 2, so that means I need, what, 6 more to get 8? So my dot's going to be right there. Okay. Let's see here. I'll put that as 1 and 1. We'll go 2 and 3. And then when I do this, I'll do a 3 here. So that would be 1, 2, 3, 4, 5, 6, 7. And then 7 on the other side. So that's 2. And then I need to go 5 more to get 7. There would be my point 3. Now, point 2 should be pretty easy to fill in without doing all the counting because 3 and 2 are 1 apart over here. So they're also going to be 1 apart over here, and it would be the mirror image. 2 is underneath 1. So there would be my point 1. I connect everything. There is my right triangle reflected over x equals 2. Okay? And again, this kind of note, x is going to be vertical when we do these kind of things here, when we do the reflection lines. All right, now, again, a little bit different here. You know that the y-axis is the one that's going up and down here. This is the y-axis. But when we do a reflection line of y equals something, it's going to be, again, the opposite. So this is actually going to be horizontal. So we're going to want to have the line going like this. So here is -2. So our line is going to be going horizontal through -2. Just like that. Now we have our triangle down here. This kind of looks like an isosceles triangle. Probably should use a drawing tool, but I'm not going to. And again, we're going to flip this over, x equals -2. So I'm going to put 1, 2, 3, and let's test it out. Remember, this is not a reflection line. The reflection line is the one I drew right here. So 1 would be 2 away from this, so it's got to be 2 away from the other side. So there's my 1. This 2 would be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8 here. 1, 2, 3, 4, 5, 6, 7, 8 here. Okay, that's my 2, and my 3 is just 2 apart from the 2, so I'll just go over 2 there. There's my 3. Connect my dots. I've got the same isosceles well, it looks pretty different, but the dots are in the same place anyway. The same isosceles triangle on both sides of this reflection line. So remember, if it says y equals a number, okay, that's going to be a horizontal line, which is opposite of what you would think, because usually the y-axis is going up and down. Back in this example, when we had x equals a number, x-axis is horizontal, but you're going to have the opposite, which is going to be up and down here.